the recording only takes like microphone input, your voices also won't be recorded. And yeah, quick introductions, I guess, while this recording starts. My name is Serge. Like I said before, I'm the current president of this organization, along with Abraham over there.
I'm Colin. I'm a second-year aerospace major, and I run the workshops here.
Abraham, third year mechanical engineering.
Oh, Luke, first year, Becky, publicity director.
That's all I say. So, I'm still eating.
So thank you all for coming. So if you haven't already, please sign in. Has everybody signed in? Okay, I'll just give like 30 seconds to whoever.
Yeah, we can also pull this up while you guys are working with me to sign in first.
Okay. So first, who we are. So we're a UCLA student-run, student-oriented, official SOLIDWORKS user group. And so what a user group is, we're one of many user groups across the world that benefit from SOLIDWORKS official branding, but also official resources. So as a user group, we're qualified to give out certifications, certification vouchers, official resources for preparing for those certification exams, and also to connect you guys with official SOLIDWORKS events. And so to this end, our mission is twofold: to firstly communicate information about everything related to SOLIDWORKS to you guys, and also to promote further development into design and engineering in general. And we also work closely with UCLA student organizations. I believe all of you heard through a UCLA student organization and not directly through us. And also with UCLA engineering departments, we sometimes work with the MAE department for some of like department-wide emails for advertising as well. So if you guys haven't joined already, please join our Discord. This will also be shared at the end. But yeah, I'm just gonna leave this up for like 10 seconds. So in our, go ahead.
I was going to make one more ask about the facts. If you guys want facts at any point, just go up and grab them. They'll put them there for you.
So in our Discord, you can DM any one of us. It's faster than email. About any questions you have really about SOLIDWORKS, installing SOLIDWORKS, some SOLIDWORKS bugs, problems with designs and stuff like that. And also, you need to use the Discord in order to apply for certification exams. We also have a couple of good certification preparation resources there, so make sure to check that out as you're preparing. So what is the game plan for this series? So this is a 3-day series. This is the first day out of 3. This is planned to be 1 hour long, but Wednesday is also planned to be 2 hours long. So we've already covered introductions, and next we'll cover what is the CSWA. We'll go over a short intro to SOLIDWORKS, and then after that it's just basically practice. Problems that you may see on the CSWA, and their related topics, how to use the features within SOLIDWORKS in order to get the final answers, and also just what they're looking for on the exam. So in this workshop, we'll be covering drawings and sketching. And then the next workshop, we're going to be going up to parts. So the same sketches that you guys create in this workshop will be used to create the parts in the next workshop. And the final workshop is going to be assemblies. And then since it's 2 hours, we think there might be time left over to go back to parts that we missed or we didn't have time for. And giveaway is on Wednesday, right? Wednesday, okay. So what is the CSWA exam? CSWA stands for Certified SOLIDWORKS Associate. This is the first exam out of 3, or actually there's a little bit more than 3 levels, but there's associate, professional, and expert, in increasing order of difficulty. It's a 3-hour exam, and a 70% passing score is needed, so you know, it's a C. It's not too hard. It can be finished in under 2 hours if you have enough experience, so plenty of time for you guys to finish. There's no live proctor, so there's theoretically nothing preventing you from cheating, but don't do that. And it is strongly recommended to work on your local machine because if you lose, internet connection and you lose all your work, then you have to start from 0, and so we don't want that to happen.
Yeah, also, this Sunday from 1:30 to 4, right? This Sunday we're hosting a CSWA certification event. So if you guys all want to come here, we'll have some food and just be talking about SOLIDWORKS a little bit before you guys attempt your CSWAs, if you feel comfortable enough to do so. Yeah.
1 to 4 p.m.
1.
Might not take all that time, but we gotta want to do it. Or like the test lessons.
So topics covered, this is just a very broad overview. We have sketching, we have features made from those sketches, and revolves, sweeps, and lofts are highlighted here because you may not necessarily encounter these very often. And we'll briefly cover these in our parts creation, so that's next workshop, as well as maybe if we have time on the third workshop. Fillets and chamfers, these are your finishing features, so these are the features that are applied at the end after you've created all your previous features. Patterning, so linear, circular, and fill. Feature conditions, so this goes along with actually bullet point 2, I don't know why they put it all the way down there. Mass properties, materials, these two go together, so materials is how SolidWorks calculates your final mass, your center of mass, things like that, and that's actually what the CSWA is looking for. So it'll give you like a drawing, and they say make this part, and then what they ask you at the end is the mass. So in order for you to find that mass, you need to apply material, you need to value mass properties, stuff like that. So we'll show you how to do that. Inserting components, this is for assemblies and standard mates, as well as a few advanced mates as well that are not listed here, but very few advanced mates. Reference geometry and drawing interpretation. So drawing interpretation is actually, it should be bullet point 0 because that's what, allows you to create your sketches, your parts, and your features in the first place. But I think, in my opinion, the single most important skill for the CSWA is drawing interpretation. Because without that, you don't know what to create, you don't know in what order to create, you don't know what to click, so on and so forth. So why take the CSWA? So of the 3 million, there's likely far many more users that have not officially registered their SolidWorks product. 10% have CSWA, 3% CSWP, and only 0.1% have CSWE. So if you have it and someone else doesn't have it, there's a very good chance that you will get the opportunity over the other person, especially if the job requires CAD experience. And it is a very high benefit to cost ratio because there is no expiration. So if you take it once in college, you never have to take it off your resume or LinkedIn forever. So it's pretty good. Exactly. Exactly. So this is an example drawing of what you might see on the CSWA exam. Although, correction, you won't actually see this whole sheet because on the exam, they're kind of weird and they only give you each view individually. So for example, oh, I have a mouse. Okay, so for example, they only show you like this one view, and then they'll show you this next view on a different page, and this one, and then this one. But in industry, you won't see them separately. You'll see it all together on a sheet, so I think it's useful for you to be familiarized with what components are in an actual drawing. So first of all, before we actually get into these views, we can go ahead and cover the title block, which is down here. It's really small, but I'll just like say what it actually says. So first, of course, the title block, its name as a title. This is the title of the part. And then the important thing, one of the important things is down here. You may barely be able to see it. It says weight, and it says 0.010 pounds. So this is what you're going to be inputting into your testing client. This is what, is the final step, and then you input that in, and then you move on to the next question. And it's not just the weight in itself, the value itself that's important. It also tells you what unit system the drawing is using. So in this case, it's using pounds, so that you know it's in American units, or and SolidWorks likes to call it IPS, inch, pound, seconds. The alternative is MMGS, which is millimeters, grams, seconds. So if it was an MMGS, it will give you the weight or the mass in grams. But in this case, since it's in pounds, we know we need to dimension everything in inches and not in millimeters, because that's going to give you a completely different mass. Next, we can look here. It says material 6061 alloy. This is important because SolidWorks uses the density of the material that you apply and the volume of the part that you create to calculate your final mass. So if you apply the wrong material, then you're going to get the wrong mass. We'll show you how to apply materials for parts in SolidWorks, but it's actually really easy. It's just a simple right-click, you search for the material, and you apply it. But it's important to get this right. So any questions so far? No? Okay, awesome. So moving on to the actual drawing views. Here we have a couple of different terminologies for types of drawing views. In the top right, you'll see this view that looks very much like a completed part. It looks like a completed model. This is what we call our isometric view. And the isometric view is generally supposed to look like the final model, right? And it's called isometric because you can see 3 perpendicular views at the same time. So imagine if you had like block. Isometric is when you can see the top, the front, and the right faces all at the same time. So 3 views, or 3 faces at the same time. That's called isometric. And then we have what are called projected views, to the left, diagonally, and to the bottom. And so projected is literally taking a face of that part on what it will look like if you looked at it from the side, and just projecting that on the 2D plane. So this is what's called a top view. So if you were to look at this from the top, like straight down, this is what you would see. And then same for front. So front, I mean, it's like this, and then this angle face, and so it translates into 2 rectangles. Then from the side, then you can see you have this kind of wedge shape, and then so it also translates neatly over here. One other thing to note is that you may notice that there's dotted lines in this bottom right view, which is the right view, but there's no dotted lines in any of the other ones. And so these dotted lines are what is called hidden lines, and they show geometry that is hidden behind the front face. So if you looked at this right from the side, and you didn't have hidden lines turned on, you wouldn't be able to see like the holes behind it, you wouldn't be able to see this kind of ledge behind it. But with hidden lines enabled, you can now see these dots. And so these kind of help you give like a spatial understanding of your part. Not all drawing views will include this, but if you see dotted lines, think hidden lines. One last thing is dimensions, right? So these are very important, of course, for creating your parts and your sketches. But in this drawing, we have 3 types of dimensions. We have linear dimensions. So these indicate things like length, width, height. So you have 0.25 inches here, 1 inch, 0.5 inch, right? We also have diameters. So we have this, 0.13 inches for this diameter. And actually for this one as well, it's implied because they kind of look the same size. And then lastly, we have radial dimensions. So down here, we have radius of 0.06 x3. So x indicates multiplied by 3, and so you can kind of see there's 3 rounded corners. So that's 1, 2, 3, right?
Yeah, and also, it's not pictured on this part, but there's also the angle dimension, and it's just the angle between 2 lines on the drawing.
Yeah, and also you might see pattern dimensions. So if you have like a series of parts and it says x something, then that means that it's a pattern, and the number after the x indicates how many features are in that pattern. So before we go to the next slide, any questions? Pretty basic so far. Okay, nice.
Awesome. So now we have a little cheat sheet that has drawing views. And how many of you guys didn't get the email that this is talking about? But for the rest of you, it should look like this. Does everyone have theirs? Awesome. But this just goes over 6 views that are very likely to be on the exam, and then 4 that may or may not be on the exam, depending on like the difficulty of the CSWA. But the first one that you're going to want to definitely know is a break view, which is somewhat pretty self-explanatory. It's just a broken section, kind of in the middle, if there's nothing really interesting going on there. A detail view could just be like a little circle that's magnified. That's also a little self-explanatory. And then the crop view is sort of similar to the detail view. The detail says a specific scale, but the crop view can be anything. They're pretty similar. Oh. Do you have a question? Oh, the PDF. Oh, wait, how many, so Ray's tall hand, how many didn't get it? There were 3? Oh, 4, oh. Interesting. Does everyone understand these 3 views though, generally? But yeah, you'll have this PDF to reference, and even when you're taking the CSWA, you could reference this document because technically there is nothing to really stop you. And then two also important ones that might be on like multiple choice, because basically the way the CSWA is structured is there's going to be 3 sections. The first section is going to be small questions, including like what view will give you this, like what's the name of the view that will give you this image. And then parts 2 and 3 are parts and assemblies, which we're going to touch on the second and third days. But this first day is going to be about like the views to kind of internalize those. Does that make sense, everyone? But yeah, a section view is when you have 2 letters typically, and it will tell you which section it is. And it's basically, if you take a plane and slice it down the middle, right where that line is, when you look at that plane, that's what's going to give you this little image right here. And then an aligned section view is similar to the section view, it's just, it's not a straight plane, it could be aligned in a different way. Does that make sense to everyone? But both of them will say section AA, so, or just something like that, like JJ, DD, something like that. And then a broken out section view is when instead of forming the entire plane through the entire object, it's just a little small broken out part of that. And that's just the terminology that I guess we use to do this. Does that make sense, everyone? Cool. And then here are, you don't really need to know this for the CSWA, like it won't ask questions on these types of views, but when you see the part on, for example, like this drawing, there's 3 projected views. That together is called the standard 3 view. So if you were to, like, if maybe like your professor asked, hey, can I have like a standard 3 view of something, if you're I've never taken the CAD class, so I don't know if he's going to ask that, but like that's what we refer to as a standard 3 view. And then 4 projected views is the similar thing, but for top, bottom, left, and right. Cool. Any questions on just like the drawing views? And you can take like time to internalize this. You have the PDF as well, if you ever need to reference it when you're taking a practice exam or just like looking over the questions and stuff. Sounds good? Cool. So, for example, I guess, yeah. Here's an example question. Would anyone like to volunteer to answer this? Feel free to reference your PDF as well. Yes, crop view, because it's like, you take, because the way you make a crop view, so let's go back to this document for a second. So a detail view is, I'm pretty sure a detail view is always a circle, but a crop view, the way you make it is you actually create a separate feature, a sketch, and then make like a little line, and whatever's inside that line is what you can view in that crop view. And so the way you can distinguish these two is just if it's not like a straight box or a circle or something, then they'll just be like a crop view. So you can also do this by process of elimination, because in the isometric view, for example, that was when you could view all 3 sides of this, and this is not, because it's asking what B is. B is not an isometric view because you can't see the entire part. And then a projected view is you're not viewing it straight on. And then the section view, there wasn't like a dashed line that said AA or something like that. So that's how you roll out the section view. And section views are pretty easy to identify because they say section AA or something. A is an isometric view, yes. And then what about this one? I don't even know if you, okay, so right up here, it actually shows there's like a little bit of like a line sketch that kind of outlines the same thing here, but it's just a dashed line. Close, because it does take a small section out of the object, but it's a specific one. Here to like go back to the document a little bit. It's one of, yeah, these 3. So here's the slides again. So yeah, which creates this view from this? Yes, correct. I don't know if we have an answer side for this, but it is the broken out section, because as you can see, it's essentially if, like, this is a very helpful graphic Suraj found, and it's basically like if you just take a part of it and break it out, so that when you look at it, it's like you're looking kind of at an X-ray view, and that's what it looks like here. So, that was technically another little show. But yeah, do you want to do the SolidWorks here, or do you want me to? All right. So, do you guys all have SolidWorks open right now? So yeah, if you need to go back from the very start, it'll take you to this, and then you just click New Part. I'm gonna close out this part. And then the very base of everything that you're going to do in SolidWorks, in order to make a 3D object, we're going to have to create something in 2D for it to make 3D from the ground. And how many people have used CAD in general before? Yeah, show hands. Okay, so good amount of you. But yeah, the way we do that is in what's called Sketches. And when you click the button that says Sketch, it's going to be under this tab up here. It's going to ask you which plane do you want it on, because again, a sketch is a 2D thing, and we need to create it on a plane first. So just arbitrarily, I'm just going to choose the front. I was supposed to choose the top. Okay, well, any plane. And then right up here in the top left corner, you're going to see all of these. I wonder if I can even like zoom in with the UI. I don't know how to edit the UI size. Is anyone having trouble seeing the top left? Because I guess my computer might be kind of difficult to see from. All right, cool. Never mind then. So I guess I can just run through real quickly what these do. A line, the way you access it is by clicking it, or you can press L on your keyboard. That accomplishes the same thing. And you can just make like a line, like a little box. And one thing that SolidWorks will do is it will sort of snap it to whatever it thinks you might want to do. So for example, this right here is a vertical line. This will snap to like horizontal, and it will give like a little blue thing like, yay, I'm helping you out. And it will sort of also interpret other things, such as this being horizontally aligned to the origin. But you will need to do other things in order to make sure that it doesn't move, because I can still move it. Everyone following along so far? Ooh, I did the cardinal sin of not setting my units before I sketched. So don't do, I mean, eventually you need to set your units. So if you go down to the bottom right, down here, you can't really see it on here, but it's going to say custom. And depending on what the part says, you're going to want to go IPS, so inch, pound, seconds, imperial, or MMGS, millimeter, gram, seconds. These are going to be the two that were on the CSWA. I'm just going to click millimeters because we're not savages. In order to make this, so basically, the way that CAD software creates your part is, in order to actually make your part, like your part that's unique, and like it's not going to make this rectangle versus this rectangle, you're going to need to specify how long it is, and just specify the dimensions. And that's called that's what's called defining our sketches. And so, for example, I'm going to make this line 50 millimeters long. And now I can't move this because it's fully defined, because right at the bottom right here, I started this entire thing at the origin. So it's locked to where the origin is 0, 0, 0. And this is 50 millimeters to the left, and it won't be able to change. Any questions? Nice. And if you have a mouse, you can also hold down the right click, and it's going to give you like kind of a wheel, and you can like go up and down in order to access these things. And then I'm just going to dimension this to like 40 or so. And now at the very bottom right here, it's kind of hard to see. I wish the projector was a little bit better. But it should say fully defined, and all of your lines or curves or whatever you're making on your sketch should be black. Does that make sense to everyone? Anyone having trouble getting it to say fully defined down here also? Sometimes you have to look really closely because maybe a vertex will appear blue, and then you can drag that vertex around, but maybe not the entire line. So what we're looking out for on the bottom here is it's going to say fully defined if it will allow you to actually look there on my computer. So now that we have that, here's the circle tool. This is the center circle, so you can click on the center, drag it out. Here's a 3-point circle, so say I wanted a circle that included 3 of these vertices. I click 1, 2, 3. And then because the circle is uniquely defined by 3 points, this is fully defined by default. Whoa. What happens? Oh, is it uniquely defined by 3 points? Or more? I don't remember. Okay. Oh, here's the 4th point. Yeah, I don't know. Okay, well anyways, the circle tool. One thing that's also helpful that specifically particularly remote desktop users should also know this. If you press S, that'll give you a shortcuts menu. So you don't need to actually drag your mouse all the way up here. And you can just have a certain amount down here. I use this very religiously now. And if you want to edit the commands on here, once you know what all of these commands do and want to add more, you just right click and then select customize. Then you can just drag these onto the shortcut bar, like I drag this over here or something. That's just a quick little SolidWorks tip that I use a lot of the time. But anyway, so we got the lines and the circles. We're going to skip the spline and the style spline. That's usually used if you want to like have an image and then sketch something over that image. That way you can project it. The assembly on Wednesday will deal with that. You won't have to create the spline, but the part was made using a spline, and I'll explain that. And then here's the rectangles. There's the corner rectangle, so you can just specify 2 corners, and it will create it. There's the 3-point rectangle, or the center rectangle, which is similar to the center circle, and it just, you can place one of the vertices somewhere. This is an abomination. It will also create these construction lines. So one thing that I guess I have not gone over yet is in the lines specifically, there are these things called center lines, which are also called construction lines or construction geometry. And basically, here, let me sort of make an example. So when, this is me jumping ahead a little bit, but I'm going to create a construction line shaped like right here. All 3 of these are going to be construction. And what you're going to see is that there's no solid color in here because it's construction. It's only for constructing the sketch. You can't actually do anything with it. So I'm jumping ahead, but if I was to make this into a 3D object, I can select the circle, I can select the rectangle, but I can't select the construction geometry. So when you actually go to make a 3D, SolidWorks is going to not register the construction geometry as anything because it's just a useful tip to have or tool to have when you're trying to make sketches. Any questions so far? Awesome. Is the pacing good? Should I go a little faster, a little slower? Yeah. Like which of the circles, or? No, because the solid lines are all, the solid black or blue lines are all just normal geometry. And then this dashed line right here, you can see like when I hover over it, it's dashed. Oh yeah, you can see a lot better here. And then right here, let me align it better, there. These are construction geometry. And like if I constrain it, and like it might be, I'm gonna try to make it so it looks a little better. No, what? But yeah, they also can appear black. So black just means defined, blue just means not defined. I'm gonna delete this. This is fun. Okay. Yeah. So defining just means that there are 0 degrees of freedom, meaning that, so for example, this, it because it's a 2D sketch, it has 2 degrees of freedom. It's already constrained only to be along this line right here. Because if you click this point, and you kind of hover over it, I think I accidentally disabled my relation like showing, which is unfortunate. But like if you try to drag like this around, for example, like it won't drag around. That's because 1 degree of freedom is constrained by this line, but the other degree of freedom isn't. So if it's showing up blue, that's because you can still move it. Anything that's blue, you can drag around and see which degree of freedom you need to constrain. So the way I'm going to do this is, because it needs to be along here, I'm going to quickly make this like 35 or something. And now it has to be 35 millimeters away from this, and I can't move it anymore. Does that make sense? How do I get that to show the eye on the top? What are the dimensions? Wait. Here? Ah, okay. Thank you. I didn't know that. But anyways, so for example, this one right here is showing that this circle is like tangent to this. This is showing that it's horizontal, which is just a straight line up to the left and right. These are vertical ones. This is coincident, so this vertex that sits right here is coincident to the origin, meaning it sits directly on top of. Yeah, any questions? Do you want to do some of these? Yeah, because I've
So just really quickly, I think we kind of skipped over this, but that's fine. So if we exit out of Sketch, right, and then say you want to view a different angle of your part, middle mouse, and then drag. And so this like little, I guess, like almost full revolution arrow thing appears, and you can rotate. And then say you rotate to some like random thing and you don't want it anymore, you want it back in its like somewhat viewable state, then you press the space bar. And then once you press the space bar, everything zooms out, and then you get this little dialogue that's right here. It says orientation. And so on here you have a bunch of different buttons to play with. You have like, this says top, then you have left, right, front. But usually you'll just click on isometric, which is this, and it brings it right back to isometric. So again, space bar, and this little box, that's isometric. It's a lot faster usually to just do Control 7, so that's a shortcut. So say I perturb it, Control 7 brings it back. Say for example also that you had zoomed in way too far into your part or zoomed way too far out, then you just press F and it brings everything back into a nice, centered view. So again, that's F. And then one last thing, if you want to pan, so pan means just moving your view left and right with no change in orientation. You do Control, middle mouse, and you can just move everything. So this is useful if you want to zoom into something that's not aligned with the origin or the center of your part. So say I want to zoom into this little dot right here. I just zoom into it, right? Okay. And so F again to restore. I think in terms of just general UI components, on the left you have what is called the feature manager. So this is what contains all of your features. So Colin before created one sketch, so you can see it's named as sketch 1 here. A part comes predefined with certain features already, the front plane, the top plane, the right plane, and the origin. The origin is just the intersection of all these 3 planes. And then at the very bottom of all these features is what's called your rollback bar. So this is pretty interesting actually. It's basically a way to revert your part to a previous state. So say for example, I wanted to do a sketch before Colin's sketch. Instead of deleting Colin's sketch and then making my own sketch and then putting back Colin's sketch back in, I just take this bar and I drag up and then boom, Colin's sketch is gone, right? And I can do whatever edits I need to make and I can pull it back down to restore Colin's sketch. So that's just pretty useful. It's marginally useful on the CSWA, but it's a good thing to keep in mind. On the top is what's called your command manager. So this has your context-aware things like the sketch bar when you're sketching, the features bar when you're doing features, etc. And yeah, sorry, I did forget one more thing. So remember how I talked about materials and how it's really important for calculating stuff in the CSWA? That's found in your feature manager. It says material. Right now it's not specified. You want to click on that, right click, And it gives you a kind of favorites bar of your favorite materials or the ones that you use most frequently. But if you have one that you can't find in here, then you just go to Edit Material, and then it pops up with all the preloaded materials that SOLIDWORKS has. So say I want like some alloy. So then you just type in alloy, and then say I want, I don't know, 7079 alloy. So once you click on it, it pops up with a bunch of different material properties. But the one we're interested in right here is mass density. So it says 2,700 kilograms per meter cubed, or cubic meter. So you can just check with, if it's the correct material or not. And then you just click apply, and you close. So right now it says, on the left, it says 70799 alloy. So this is the global material for the part, and this is good practice to define along with your unit system before you start doing anything else. Anybody have any questions before we move on to actually making a part? Still have 20 minutes. Good time. No question? Okay, sick. Awesome. Okay. So let's go ahead and open up the PDF again. And this time we scroll down. This is our first part we're going to be doing today. Oh, sorry. Colin's scroll is reversed. Sorry, it's kind of, okay. No problem. So this is the first drawing that we're going to be doing today. So as you can see, we have on the bottom right, actually, okay. Does anybody remember what the thing in the bottom right is called? This block. It's very good, very good. Yes, it's called the title block. And so in the title block, you have the important stuff. So we have the weight right down here. It says 4.93 pounds. And so because it's in pounds, again, we know that we're using imperial units, American units. And then we have the title of the block, and then we also have the material, which is 6061 alloy. So before we do anything, we can go ahead and go back to SOLIDWORKS, and we can create a new part. So that's right up here in the top left, there's this little arrow. It's usually hidden behind this arrow. If it's not hidden, then good for you, because I spent so long trying to look for this menu. You just need to click, kind of hover over that little right-hand arrow until you get File, New, and then you can create a new part. And click OK, then it creates a new part. And so on the left, you have all your normal features, your front plane, your different planes, your origin. So we want to first define our unit system. So on the bottom right-hand corner, we don't want custom, we want IPS. So we click IPS, and then we define our material. So we want 6061 alloy, which is not in the favorites list. So you click, right-click, edit material, you search for 6061, and you get 6061 alloy. And then we click apply, and then click close. So this is the initial setup done. Very fast, but very important to do. Does everybody have material on the unit system set up? Does anybody not have this set up? Okay, I'm going to assume that's okay. We're fine. Okay. So next, what we want to do is actually look at the views themselves. So as I said before, we have our isometric view on the top right, and from what it looks like, it's a pretty simple part, right? It's literally a cube that has two holes cut into it of different sizes, and both not entirely through the entire cube, right? And we know it's a cube because if you look at the top view, you can see 4 inches length, 4 inches width, and then 4 inches for the height on the front view. So the reason why this height dimension isn't in the top view is, of course, because this edge in the front view just looks like a dot or a single vertex in the top view. So we need to have another view in order to show that dimension. So we know it's a cube, and we also know that it has 2 holes, because if you look at the front view here, you can see the hidden lines again, because these are dotted lines that shows that whatever is inside the part. And we see that we have a diameter of 2.5 inches, and this is drilled down, I guess you could say drilled down, a depth of 2.5 inches, and then underneath it we have another hole of 1 inch diameter. And you can see that both of these are centered, so they're not offset across the center of the cube because it has the center line going down. So sorry, I didn't cover this before, but a center line can be distinguished in a drawing when it has a long, short, long. Whereas a hidden line, you'll only see dot, 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 dot. So there won't be any variation in the length of the lines for hidden lines, but you will see long, short, long. And once you see a long, short, long, that means that it's symmetric about that line. So I know that these holes are, centered in the middle of the cube because there's a center line there. Any questions? No? Okay, good. So can anyone tell me what they would think is the correct order? I mean, there's a lot of correct orders, but what's the way that you would go about modeling this part? What's the order of, I guess, sketches, features that you would create? Okay, nice, nice. What would you do after that? Mm-hmm. Mm-hmm. Okay, nice. Did everyone catch what he said? Yeah? Okay, good. Yes, that's actually how I would make it. But for the purposes of this workshop, we're going to put all the sketches into one sketch. We're going to combine them all into one sketch and then extrude from that one sketch. In the actual CSWA, this is not necessarily encouraged because if you make a mistake and then you combine all your sketches into one big fat sketch and then you make a mistake, then you might have a lot of work to go through. But since we're just covering sketches today and covering features in tomorrow's workshop, we're just going to put it all into one sketch. So let's go ahead and actually create that big sketch. So can anyone tell me actually which plane we should make that sketch on? Which plane? If we were to make only just one sketch, which plane would we put it on? Or combine all sketches into one sketch? Not necessarily, because you put it on the front plane, right, and you can only extrude it forward and back of the front plane, then you wouldn't be able to create a circle, right? Top, yeah, top is correct, yes, because on the top plane you can see everything, all of the relevant features in a 2D form. So that means that you can create all of the features from the top plane. So let's go ahead and go back to SolidWorks, and on the top plane, we want to make a sketch, right? So there's two ways of creating a sketch from a plane. You can either right-click on it, and then right here, there's this little sketch button, or as Colin did, you can also click on sketch, and then click on the top plane. Either way is fine, same end result. If it happens that you do not get a properly oriented sketch view, so for example, if it's slightly offset, like this, or if it's like some random orientation, and what you can do is right-click on this sketch, and then click on this little normal to, and so it'll automatically reorient it normal to your view. So this is important because, I mean, if you make a circle and it looks like an oval when it's supposed to look like a circle, then you know that you need to make a normal to. So once you have this, then the very first feature that we can make, we can start from the inside and go outside. So we can start with this little circle first in the middle. So we know that this has a diameter of 1 inch because if you look down on the front view, you can see it has a diameter of 1 inch, right? So we can use a center circle. So again, that's right here in the top left. You hover over it, it says circle. And you click on circle. You first select the center, and then you select the circumference. So that's 2 clicks. And once you create 2 clicks, you can press escape to deselect. Then you get a blue circle. And so remember, Colin said blue means underdefined or not fully defined. And so that's reflected down here. It says underdefined. It's also reflected in the left on the feature manager, where you see this little minus in parentheses. That also means underdefined. Once it's fully defined, you won't have a minus anymore. So in order to fully define it, we need to add a dimension. So we click on Smart Dimension, and we click on the circumference of the circle, and then we give it a value of 1. Press Enter, and then right now it says diameter of 1. That's pretty simple. Everybody good with the circle? Okay, nice. So next is the next biggest circle. Again, repeat the same process, 2.5. So you select the center, you select out. We know it's bigger, so you put it out. We do Smart Dimension, 2.5. Press enter, everything's black again, fully defined. And last one we want to do is just make the square, right? So we know it's width of 4, length of 4. So we can use the center rectangle for this. Click on center rectangle, click the center, go out, and then we need to add 2 dimensions, one for the length and one for the width. So we add 1 for the width, 4, add 1 for the length, 4, and now everything is black, and we have fully defined. So this is actually the end of the sketching procedure for this part. It's a pretty simple part. Does anybody have any questions before we actually move on to the next part? Yeah. Okay, I'll give like 30 seconds before we move on to the next one. Purple hourglass. What? Let's move on to our next part. This one's slightly more complicated, but I'm sure you guys can get through it. So we'll just go ahead and scroll on to the next drawing. So this is the latch. This is, as you can see, is slightly different. Looks slightly different than the cube, the drawing itself, because in the top right, our isometric view is no longer shaded. So it kind of just looks white, no color. But again, it's still isometric view. Nathan, who is another workshop leader, he actually said units IPS here, which is nice, removes ambiguity. But you could have also inferred that by the weight down here, which is 0.059 pounds. So here we're actually missing a couple of views, right? Can anyone tell us, can anyone tell me which view we're missing? Which of the standard views are we missing? Top? Or, yes, that's correct. We're missing the top view. So we can see the front view here, we can see the right view here, but there's no top view. And there might be a couple of reasons for why you want to omit a view. One, in this case, maybe you just ran out of room, so you didn't include the top view. Maybe the top view doesn't have any relevant dimensions, so you just remove it as well for brevity. But either way, we should be able to completely model this without the top view. And so again, this is a single sketch part. And so in this case, we do want to make the sketch on the right plane because we see in the right view the most amount of features or the most complicated sketch. So we'll go ahead and create a new part, file, new, part. Right click on right plane, sketch. So we have a sketch on the right plane. And here is, I guess, one of the nice to haves or one of the good practices to follow for sketching is to always sketch to the origin. So your first feature should always be constrained relative to the origin. And so this kind of just comes from experience, but if we look at the part, we can see there's a center line, kind of dash center line here, that connects the center of this circle, half of which is cut out or left out, and this circular cutout, which is fully present. So then I know that I need to have, a horizontal relationship between these two. And the best way for me to do that is to actually just make one of these circles centered on the origin, right? So if I wanted to make this circle first, So we know it has a diameter of 0.25. Oh, sorry. I forgot to specify my material. Okay, sorry. Material is cast alloy steel. I also need to change my unit system to IPS. Okay, sorry about that. Okay, right plane again. We want to create our first circle centered on the origin with the diameter 0.25. So you just dimension it 0.25, enter. And so that takes care of this circle right here. Next, what we want to do is actually create this bigger circle that you might not be able to immediately see. But if you imagine that this circle was not completely, was not cut off, and its full circumference was here, then there will be a circle here with a radius of 0.375. So we'll go ahead and create that. And we know it's concentric, or we can infer it's concentric, because, well, it kind of looks that way. There's no actual, like, visual cues for that, but we can just infer that it is concentric. So we'll go ahead, go back. And this time, instead of a diameter, because the dimension defaults to diameter, we can just go ahead and actually do a little bit of math within that window itself. So SOLIDWORKS is pretty smart. So radius, right, diameter is 2 times the radius. So we can just say 2 times asterisk, times is an asterisk, 0.375. And so we press enter, SOLIDWORKS automatically resolves that to a number, and then it gives us the diameter. Alternatively, you can just create a dimension, you can change it to radius, and then you can just put in the value of the radius, but either way is fine. So now we have these 2 circles. Next, what we want to do is actually create these 2 lines that go out from the circumference of this bigger circle. So this is actually quite simple. We'll just go ahead and select line. We'll go here. You can kind of hover over, and it'll actually give this little diamond. I don't know if you can see it, but it's this little orange diamond that indicates kind of the point that's vertical to the circle's center. So if you click on this, go horizontal out to the side. That's 1 line. And then we'll do the bottom line. So now we have our 2 lines. Now, the interesting thing is we don't necessarily know how long these lines are, but other dimensions will solve this dimensioning for us. So let's go ahead and actually just create the other stuff. So we have this little line here that goes off to the side, down to the right. Actually, we came to the point where we ran out of space. So we can just drag everything to the left a little. Wait, Colin, how am I on time? 7:56. Okay, 4 minutes. Okay. Then next, what we want to do is actually create this small little circle here. What? That's speed. And actually, for this one, we can be a little creative. We can actually use an arc instead of a circle, because we know that we're not going to use a full circle anyway. So we'll go ahead and actually, the arcs are here. So right underneath the circle is the arc. And we can use a center point arc, because we know that we want to make the center of this arc horizontally related to the origin, right? So we just go out left of the origin. We see this little nice, helpful little dotted line that SOLIDWORKS gives us, saying that we are, in fact, horizontal to the origin. Press enter for the center point. We press we don't press enter. We left click for the circumference, and we do another left click for how much of an arc we want to trace out. So I'm just going to put it like, I don't know, right about here. Press escape. So now we have a little arc. Okay. Now we want the endpoints. Or actually, let me think. Okay, so we want this. Yeah, we want this arc to actually be tangent to this line. So in order to do that, you can just go ahead and actually manipulate it a little bit. and we click on the circumference of the arc, and click on the line, and then we get tangent. We click tangent. Okay, that didn't do what I wanted it to do. Okay, let's try again. Oh, sorry. And in order to select multiple things at a time, you just press Shift or Control, and you click both. I click tangent. Ooh, it still didn't do what I wanted it to. Okay. Okay. And then we want to make, of course, the end point of this arc. I'll zoom in. The end point of this arc coincident with the end of the line, and so use Control, select these two, do coincident. Okay, so now what we have is this arc is tangent with this line, and it's coincident with the ends. Okay. Next, what we can do is, again, the center point of this arc is horizontal with the origin. So we do Control or Shift, select both, click on horizontal. Nice. And then last thing is that if you look at this, if you look at the drawing, you can see that the line, it approximately intersects the edge of the circumference right at where the tangent is. So that's like right at the 90-degree angle. And so we can just do that quickly. So in terms of relations, that would be making the endpoint of this arc actually horizontal with its center. We do horizontal. And one last thing is the radius of the arc itself. We can see that's radius of 0.25 inches. And so we'll just go ahead and dimension that. 0.25. Okay. Awesome. And then one last thing is to just make this horizontal line that connects this vertical line that connects to this horizontal line. So you can just draw a line down from the end of this arc down here. And so now we arrive at a situation where I could either dimension this point coincident with this line, or I can use what's called power trim. So power trim is pretty powerful, sorry. But if you look on the top here, it says trim entities. You click on it. It gives you this kind of like, this kind of like drawing tool. And if you press and click and you hold down, it gives these little gray lines all over the place. So whatever you draw over, it will be cut. So for example, if I wanted to cut this section of the line but not this section, I just do a nice little drawing over it, and then boom, it cuts it. So it just removes everything that it comes into contact with up until the next coincident mate. Did everyone catch that? No? Okay, I'll do it again. So you have this hanging leftover piece of line that you want to get rid of, right? Because you don't want this line. It's going to make issues, right, when you want to actually try to extrude it. So you want to get rid of it. So there's two ways of doing this. One, you could either make the endpoint of this line coincident with the endpoint of this line. So you can go here and click coincident, and it'll move the line to the appropriate place. Or you could use power trim. So on the top, trim entities, you click on trim entities. It gives you this nice little gray drawing tool. And wherever this gray drawing tool intersects, it cuts that portion. So cut it. So it cuts up until the next coincident mate. So in this case, the next coincident mate was this, I guess, or where it intersected. So just trimmed that excess geometry. Good? Okay. Awesome. Okay. So now is a case of trying to figure out what else we have. So we missed this 1-inch diameter between the circles. So we'll go ahead and do the dimension there. Center of this one, 1. Okay. And then what is this? Okay, so it's this. Okay. Let's see. Okay. And here is the angle dimension. So you can see there's a 60-degree angle here. So to do angle dimension, you just select two lines. So you do smart dimension, click this line, You want the interior angle, not the exterior angle. So we'll go ahead and do interior angle of 60. As you can see, everything became black. There's no blue lines anywhere, no blue dots, and you can see on the bottom right, or sorry, you can't actually see, but it says fully defined. On the left, you can see there's no minus next to sketch 2. So we know it's fully defined. And just a little bit of cleanup, we can once again use power trim. So if we go up to trim entities, and then we want to remove this half circumference, right? Because we don't necessarily need it. It doesn't appear in the sketch anywhere. There's no, half circumference here. So we can just use power trim and then takes it away. And then you get this nice shaded geometry to show that's fully enclosed. And yeah, that's actually basically it for this part. Yeah. Yeah, sure. So the angle dimension, let me just remove this dimension. So as you can see here, it's blue, right? That means that I can move this point. You can see the angle here is changing. So angle dimension, you just click Smart Dimension, and then you click these 2 lines. And then you can either specify the exterior angle or the interior angle. In this case, we want the interior angle because in a drawing it shows the interior angle. Although the 60 degrees is written outside, the text is written outside, but it's not exterior because the arrows point inward. And so we want this, and then we click, and then we say 60. And then once again, it's fully defined. Does everybody have something that looks like this? Power trim? Yeah, sure. Power trim for the circle? The bottom line. Okay, sure, I can go back. So just Control Z as usual to go back. Okay, so with this hanging geometry, right? So you go up to Trim Entities on the Command Manager, you click it, and then you just click and drag, and then whatever your cursor intersects, it'll cut away. It'll cut that away. So of course you don't want to go around like, oh no, I just cut everything. But like you want to cut what you want to cut, right? So you go down, you want to cut this line, and so you cut it. And you want to do the same thing again for this circle. But let me just go ahead and go back. Actually, oh, lol. Okay, I just need to create all my dimensions again. Sorry. Okay, I don't think we have time to go through our last and final part, but make sure to keep these sketches for next or for tomorrow's workshop. We'll actually go into creating these as features and maybe go into creating sketches for the third part. If you guys have time before tomorrow, go ahead and look over that third drawing. So it's this one. It's the web block. This one is significantly harder than the previous ones, but there isn't, let me think. There is not much new features here. There's just a lot of complicated geometry. And so if we have time tomorrow, we will go through this. But yeah, if you have time, look over it. Think about what you might want to make first, make second, how you'd extrude things, which planes to sketch on, and so on and so forth. Yeah. Oh, shoot. Okay. Yes. Okay, I should briefly cover that. So these, thank you for the reminder. These are actually sketch fillets. Completely forgot about them. So if you go to, this is not fully dimensioned or fully defined because I went back, but sketch fillets are this little thing on the bottom right of all the different features that you can make. You click on sketch fillet. It wants 2 lines that are perpendicular to each other or just coincident to one another. So we want this line and this line. And so you can see it creates this radius here. And you can specify how big the radius is but under fillet parameters. So in this case, we want a radius of 0.125 inches. So 125, press enter, changes the diameter, press enter, and then out pops the radial dimension. And so actually you want to do the same thing for this one as well. This one is actually a diameter, but you could just divide this by 2 to get the radius. So as an example, you click on these 2. We want it to be half of 0.0625, so we get 0.0625. All right, 2, press enter. enter, and then we get that nice little rounded corner. Any questions? Okay, awesome. Okay, I think with that we can end here. Sorry we went over time, but hope to see you guys all tomorrow. Tomorrow we'll be covering again features and creating features from these schedules. So if you guys have questions, feel free to stick around, or if you want to ask us questions on installing SolidWorks and other stuff. But yeah, thanks for coming.